Hey guys, welcome back to the channel. Hope you guys are doing absolutely great. So today we'll be discussing about an interesting problem statement. It says combination sum 1. So it is type 1. We have two types of this. I can say we have two variations of this problem statement. So this is the first variation, right? So let me elaborate on the problem statement that we have here. So you will be provided with a array which basically consists of integer. I mean the integer array will be provided to you. In this scenario I have taken a sequential number 1 2 3 4 as a input array, and you will be provided with a target sum. And again in this example I have taken 4 as a target sum. So the requirement is that you have to find out all possible combinations of number from this input array that has been provided to you, such that the summation of that data set will come to 4, right? For example, 1 1 1, or if I take 4 ones, I can get the target sum as 4, right? If I take 2 ones and 1 2, then also I am getting a target sum of 4, right? Again, if I take 1 and 3, I get the sum as 4. 2 and 2, 4 is 4, right? So I hope you got the problem statement here. One thing to note here is you are allowed to take multiple instance of any element in this array string, right? You can take one instance of one, or you can take 2 3 4, or any instance of one, or in fact any of the element in the given input string. So this is the key thing to note here, right? So let's proceed with the recursion tree. It would be much better to explain, and it would be much simpler for you to understand if I draw a recursion tree, right? So suppose here is my recursion tree, right? Suppose I have a function, say f, and I am standing at position 0, index 0, right? And my target sum is 4, correct? And my data set is currently empty, right? Let me mark the indexes here, 0 1 2 3. Fine. Now again I have two choices here. I can include the element in index 0, or I can exclude the element which is located at index 0, right? I can have this element located at index 0, that is 1, in my result set, or I can exclude it. In case I include it in my result set, what would be my recursive function like? So my recursive function will look like this: function f. What would be my index here? Will it be 0 plus 1, or will it be 0? I mentioned that you are allowed to use the same element again, right? So your index will be 0. You will not move the pointer here when you are including the element in your result set. You will keep as it is, because you are allowed to take the same element again in your result set. So you have to have the same index number in the next recursive call. So that's why I have kept here 0, right? um, so you have included the element at the 0th index first time, right, at the first recursive call. So what will happen to the target sum now? You initially had 4 as a target sum. Now because you have included element at position 0, that is 1, in your result set, your target sum will obviously be reduced by what? Reduced by you will remove 1 from this 4, right? 4 minus 1, so it will be 3, and your data set will contain the element that you have just included, that is 1. You have included 1, that's why you have 1 in your data set, right? uh, and what if I have not what if I have excluded this element present at index 0, that is 1? Then my recursive call will look like this: function, I am excluding 0th index, so my index will go up now. It should be 1 now, because we are excluding the zeroth part. And what will happen to the target? It will remain as it is because we have not included any element in our result set, so it will remain as it is. And what will happen to our data set or our data structure? It will be empty because obviously we have not included any result set, have not included any element. Then obviously our data structure will be empty, right? So this is the whole idea. We have to just create a recursion tree out of this idea that I have just explained to you, right? So let's go ahead with the left portion first. So again I have two choices, yes, no, right? So I am currently at index 0. My requirement is 3. Data structure contains 1. If I include the 0 position again, can I include it? 1. Requirement is 3. Yes, I can include it. I again will have 0 as an index in next recursion call. 3 will become 2 now, and 1 will become 1 1, right? What will happen in this case? Function 0, it will be incremented by 1 because I am not considering 0, and this will be same, target will be same, and this will be same, right? Now let's expand this. Yes, what will be my function call like? I still be in 0. Requirement is 2. 0 contains 1, so it will be 1 1 1, and now 1 will be added. That's it, right? And so we have not case here, so function 0 will be incremented, 2 will stay as it is, 1 1, right? Now again we will expand this, yes case, and we have no case. So here function, we are still in index 1, and we are including this element at index 0, so 1 will be exhausted, it will be 0, and my final data structure here will be 1. So this is the base case here. Whenever my target reaches 0, this will be my base case, right? And what will happen to the n, I mean when we exclude? So here is my function call, index will be incremented, 1 will stay as it is, 1 1 1, right? Makes sense? Now let's expand this further. Yes, no. Now what will happen here? If I include, the requirement is 1, and I am at index position 1. What is the element at index position 1? It is 2, right? Requirement is 1, we have 2, we can't take it, we are at the dead end here. So this chain is ended here. What will happen in if we exclude the element? So function, we are at 1, requirement is 1, we are at 1, requirement is 1, again we are at dead end because requirement is 1, but at the index position 1 we have 2, right? So we can't take it, or we can't exclude it, we are at the dead end. So this is also a what we call is the base case, right? We have to remember this. Now what will happen here? Again, two cases, yes, no. Now function I is obviously 1 here. At the 1th position requirement is 2, and what we have 2, so it is exhausted here, and this will be like so, right? And we will do similar thing in rest of the cases, right? Here and all those cases. I think you got the idea here. So if you notice here, this was our base case, and the data set, the value in our data set is 111, right? We have 111 here, and here also, this is also, here also we are hitting the base case, and if you see the value here, it is 112. So this, right? One point to note here, we have to add one here also. There are four ones here in the data structure. I just missed out that. So we are satisfying these two conditions. I mean, we are getting these two uh, expected output in the recursion tree itself. If you do, or if you can solve for other recursive tree for other function calls, you will easily get these values as well, right? So I hope you understand the concept here. You understand the recursion tree here. Please go ahead and create the whole recursion tree. It will be really helpful to understand, and with that, I think I will write a pseudocode for this here. So let's see how the pseudocode will look like, right? Okay, let's understand the pseudocode now. I have written a function. It will take three parameters. One is I, which is the index, and then I have a temp data structure maybe, and I have a variable called sum, right? Now let's write a base case, right? Every recursion program needs to have a base case. So in my base case, I will say if my I is greater than equal to n, that is whenever my I is reaching the n, that is the last element of my input string, what I will do is I will check if my sum is equal to 0. If my sum, this one, right, the target we are talking about, if my sum is equal to 0, what I will do is in my result dot add what, temp, whatever data structure is there, I will add to my result data structure. Suppose I have a result here, result, which is basically a list, right? So I will add this data structure in my another data structure, which is the final data structure, which I will use to print, right? Once this is done, I will say return. Understood? I hope this makes sense, right? Now coming to the main logic here, we have two cases. Either we include the element in the given index, or or else we exclude the element in the given index, right? So what will happen in case of include? What will happen in the case of include? So I will say if and only if my array of I is smaller than or equal to the sum. So what I'm saying is uh, array of I, for example, in my zero index we have 1, so array of I is 1 and is smaller than equal to sum, so 3. Is 1 smaller than 3? That is what I am checking. In that case I have to do the further recursion, otherwise I have to stop, right? Here is the scenario for stopping, right? So what I will do is, if my array of I is smaller than equal to sum, I will add it to my data structure, temp dot add, right? Temp dot add what? Array of I. Got it? Got it? Once you are added it, I will call the recursion again. Function. I will call the recursion again. Once this is satisfied, and in the case of inclusion, I will call the recursion again. Index will be same as I mentioned in the recursion tree. It will be as it is, and my temp, what will happen to the temp? It will be as it is, and sum will be reduced, sum minus array of I. Write it. Got it? What will be the next set of action? We will do the backtracking now. temp dot remove the last item we have added. The element that we have added here should be removed here, right? Why backtracking is needed? If you are in this position, or I can say if you are in this position and you want to move to this function call, how will you do that? You have to backtrack and come here, right? So that is what we are doing here, right? So this is done for include part, right? Now what about exclude? What about exclude? We will call the recursion tree here function. In the case of exclude, as I mentioned, your index will be incremented, right? It will be I plus 1. Temp will remain as it is. Sum will remain as it is, as I have mentioned. This is the data structure temp. This is the data structure temp. It will remain as it is in the case of exclusion. Also your target, the sum which we are talking here, will also remain as it is. So that I have mentioned here, right? I think that's it. This should provide you the required output, right? I will update you with the Java code for this. So this is a demo program that is written in Java for our problem statement combination sum of version 1, right? So as usual, the code is straightforward, easy to understand. We have two functions. First is combination sum one function itself, and other is main block, right? So within combination sum function, I have a base case written here, which basically checks if my I is equal to dataset dot length, that is the if my I reaches end of my data set, then I am checking if my sum is 0 or not. If my sum is 0, then what I am doing is in my result list I am adding this data structure, that is temp, right? This code does that, and then I am saying return, right? And then we have two cases, two scenarios. First is when we include a element in our result set, and second is when we exclude a element from our result set, right? So what will happen in the case of inclusion? So we will check if our element is smaller than expected target that we have, right? If it is smaller than or equal to expected target, then only we are adding it in our data structure, right? And then we will call the recursion again, and note that our input parameter is still I, it is not I plus 1 in the case of inclusion. And also note that our sum is reduced by the element value, right? Because we have included that element in our result set, that's why. Cool. Post that, what we are doing, we are doing a backtrack, right? We are removing the element from my data structure, correct? And once this is done, I am handling the exclusion case, wherein the input parameter I will be incremented by 1, obviously because we are excluding the element. So in the next iteration we will call the combination sum function with I plus 1 parameter. Temp is basically the data structure, it will remain as it is, and the sum also will remain as it is. And this is the main program, I mean the main block, wherein I am calling this function, right? So this is the input parameter 1 2 3 4, and the expected, or I can say the target sum is 4. So if I run this program, I should get the desired output. I am getting 1 2 3 4 5 sets. All the 5 sets are summing up to 4, right? This is summing up to 4, this is summing up to 4, this, right? I think I have made this problem statement very clear to you, and I hope you have got the solution, how it is solved. Okay then, that's it from my side. See you in next video. Thanks.